Hello students, today we will start the second class of force and law of motions. Okay, in the previous class we already discussed about the force, the two types of force, balanced and unbalanced force, and we come to know the first law of motions also. Okay, and today we will start the second law of motion and third law of motion. Today we will discuss the second law of motions and third law of motion. At first we have second law of motions, Newton's second law of motion. Okay, from the first law we come to know that for motions not only the velocity is the important things. For inertia we come to know that mass, that is m, is also a important things for a motions. Now that's mean for motions two important things are velocity and mass. Both are important for the motions. So before start the second law of motions, a new phenomena we have to know, that is called momentum. Okay, what is momentum? Momentum is denoted by small p. P is mass into velocity. Since mass and velocity both are important for the motions, that's why we multiply mass and velocity and name that product as momentum. That means P equal to mv. Okay, so this is the new quantity we come to know, that it is called momentum, and momentum means mass into velocity. So if m is 0, then momentum is 0, and if v is 0, then momentum is 0. That's mean for rest particle momentum will be 0. Okay, now what will be the unit of this momentum? Momentum means mass into velocity. So in SI system, unit of P equal to unit of mass is kg and unit of velocity is meter per second, that is meter second to the power minus 1. So kg meter second to the power minus 1 is the SI unit of momentum. If you go to the CGS unit, then we get gram centimeter second to the power minus 1. Okay, so this is the momentum. Okay, this is the formula to find the momentum, and this is the unit of momentum. Now we go to the second law of motions. After the first law, Newton come to observe that momentum is also an important phenomenon. Okay, for a force, mass is also important, and give the second law like that: the change of the rate of change of momentum, the rate of change of momentum is directly proportional to the applied force, and the direction of change of momentum will be in the direction of applied force. That's mean, suppose an object of mass m start with a velocity u. Okay, after time t it has velocity v. Okay, mass will be not change, mass will be remain same. So a particle with initial velocity u, and after time t it gain a velocity v. What will be the initial momentum at the time? P1 equal to mu, it is the initial velocity. What will be the from initial momentum? What will be the final momentum? P2 equal to m into v. So this is the initial momentum and this is the final momentum. Now the second law says that the rate of change of momentum, that means change of momentum divided by time. Rate of change of momentum means change of momentum per unit time. Second law says that the rate of change of momentum is directly proportional to the applied force. Where force come? The first law says that if there is no force applied, there will be no change in velocity. If there is a change in velocity, then means there is must a force. From the first law I can say that suppose the force is which is responsible for the change of motion is F. Okay, this force, that is F, is the responsible for the change of velocity. Okay, now second law says that this force F is proportional to the rate of change of momentum. That's mean the change of momentum divided by time. That's mean P2 minus P1 divided by T. Okay, so this is the second law. Now if we put the value of P2 and P1, we get mv minus mu divided by T. P2 means mv and P1 means mu. M will be common, so v minus u by T. That means m into v minus u by T. We arrange this. Now v minus u, that means change of velocity divided by time, that means the rate of change of velocity, and the rate of change of velocity means acceleration, that means proportional to ma, where a is the acceleration. Okay, now what we get? We get that finally F proportional to ma. Okay, now to replace the proportional to equal, we have to bring a constant, suppose that is k. Until the value of the constant, if we take m equal to 1 and if we apply a unit force, that means if we placed m equal to 1, that means if we take 1 kilo of mass and if we applied 1 Newton of force, then we get 1 meter per second acceleration. So if we put this value, we get that k equal to 1. That means the value of this constant is 1. Okay, so finally we get that F equal to ma. Okay, so this is the mathematical form of the second law. What is the importance? From the first law we only get the idea of force, but from the second law we get a equation of force, and from this we can say that the force applied force F equal to mass into acceleration, F into A. Okay, so if we get now the unit of force, the dimension of force, what will the unit of force? If we take in SI system, what will be the unit? In SI system, what will be the unit of force? Unit of F equal to unit of M, that's mean kg, and unit of A, that's mean meter into second to the power minus 2. So this is the SI unit of the force. We call it Newton. We call it Newton. And in CGS system, unit of F equal to gram meter second to the power minus 2. Gram centimeter, sorry, gram centimeter second to the power minus 2. It is called dyne. Okay, these are the short name. That is, Newton means kg meter second to the power minus 2 and dynes means gram centimeter second to the power minus 2. So we get the two unit of force. In SI system it is Newton and in CGS system it is dyne. Now what will be the relation between Newton and dyne? We have to find the very important question, to find the relation between Newton and dyne. So we get that 1 Newton equal to 1 kg into 1 meter into 1 second to the power minus 2. We can say that. Now 1 kg means 1000 gram and 1 meter means 100 centimeter, and in CGS and SI in both system the unit of time is second, so it will be second to the power minus 2. There is not required to change the unit of time. So we get there is 30, there is 20, that means 50 gram centimeter second to the power minus 2, and gram centimeter second to the power minus 2 means dyne. So we get there is 50, so we can write 10 to the power 5 dyne. That means 1 Newton equal to 10 to the power 5 dyne. Okay, it is very important question that find the relation between Newton and dyne. We have to start from here and we have to complete this. Okay, this is the relations between dyne and relations. When you calculate some mathematical problem, then we have required these relations. They will not provide this relation. We have to write these relations to solve the mathematical problems. Okay, so this is the second law of motion. From the second law we get the unit of force and a definition. How we get the definitions? F equal to ma. So we can say that if there is a one unit in SI system, you can say that if there is 1 kilogram of mass, okay, suppose there is 1 kilogram of mass and we required 1 meter per second square acceleration. Okay, then we have to provide 1 Newton of force. That means we can say reversely, to get 1 meter per second square accelerations for a body of 1 kg mass, the required force is called 1 Newton. Okay, that means to get a acceleration of 1 meter per second square accelerations for a body of 1 kg mass, the required force is called 1 Newton. Same like that in CGS system, what will be? Suppose it is 1 gram of mass and we required 1 centimeter per second square acceleration, then we have to provide 1 dyne force. So from here we can say that to get 1 centimeter second square accelerations for a body of mass 1 kg, the required force is called 1 dyne. Okay, so we get the definitions of the unit of force also. So this is the most important law is the second law of motions. The rate of change of momentum is directly proportional to the applied force, and the direction of the change of momentum will be the direction of applied force. We get the rate of change of momentum is directly proportional to the applied force, and the direction of change of momentum will be in the direction of applied force. That means if there is a mass of M, if we applied a force F in the direction from left to right, then the change of momentum will be in the same direction. That means momentum is also a vector quantity like force. That means force has direction, momentum has also direction. Now the third law of motion. It is very easy, and I think all of you know the third law of motions. That is, the every action there is an equal and opposite reactions. Now this is the third law of motion, most popular and easiest law, but its concept is not so easy. From the third law of motions we get conservation of momentum law and lots of other things from the third law. Third law of motion. It says, suppose if a object is kept here, if we applied a force F, then this object also gives the same amount of force to the body, but the direction will be opposite. That means if it gives F1 amount of force and it gives F2 amount of force, then F1 equal to F2, but minus. That means this minus comes for the directions. That means the directions of F1 and F2 will be opposite to each other. If F1 is from left to right and F2 will be from right to left. If it is F1 and it will be F2, but it will be the same. That means mod of F1 equal to mod of F2. The value are same, but the directions are opposite to each other. So this is the third law of motions. There is lots of applications. Suppose in this type of questions come, if we fired a bullet from a gun, why there is a recoil force in the gun? So these types of questions solved by the third law of motions. Okay, so in this class we discuss about the second law and third law of motions, and the next class we will discuss about the conservation of momentum and rest, some mathematical problem also. So today we learned the second law of motions and third law of motion. From the second law of motion we can say that the rate of change of momentum is directly proportional to the applied force, and the direction of change of momentum will be in the direction of applied force. Okay, and from the third law we come to know that every action there is an equal and opposite reaction. Okay, next class we complete this chapter, that is force and law of motion.